and welcome to this video tutorial. I'm Rowena and I'm from the product documentation team at Scaleway. This is the second in our series of practical video demonstrations to help you get started with Kubernetes. In our first video, we focused on containers. In this video, we'll be showing you how to deploy a containerized application with Kubernetes using the Scaleway Kubernetes capsule. Let's just recap exactly where we got to last time. So in our first video, we saw how to containerize an application with Docker. So by containerize, we mean that we turned our application into a portable package that included its own environment and its own dependencies so that it could run on any host machine. And we achieved this by using Docker, an open source platform for packaging applications into containers. So the different steps we went through were that we saw how to create a Docker file for our application. We then used that Docker file to build a container image for the application, and then we ran the application itself from the image on our local machine. To finish, we pushed the container image to our Scaleway container registry. So where does Kubernetes come into all this? Well, in the first video, we were just dealing with running one container image on one local machine, and that was fine. But in a production environment, we might need huge amounts of containers running simultaneously across multiple machines in the cloud. And managing that by hand is not so easy. And this is where Kubernetes comes in. So what can Kubernetes offer us? What is it? Well, Kubernetes is an open source container orchestration platform. So it's designed to deploy an application at scale, and it can automate the deployment and the management and the scaling of your containerized applications. It can also manage the life cycle of a containerized application, and it provides predictability, scalability, and high availability. Okay, so we know what Kubernetes can offer us. Let's just review some of the key terminology and key concepts that come up when we start talking about Kubernetes. There's a lot of great content out there already to explain these concepts in more detail, so I'll put some links in the description if you want to have a look at that. But let's just do a brief recap right now. So the first concept we're going to see is the cluster. A cluster is at the very heart of Kubernetes. If you're running Kubernetes, you're running a cluster. And a cluster is a set of machines called nodes running containerized applications that are managed by Kubernetes. And a cluster has several worker nodes and at least one control plane. And the control plane was previously known as the master node. Let's look a little bit more at nodes, specifically the worker nodes, first of all. So a node can be a physical or a virtual machine. In the case of Scaleway Kubernetes Capsule, a node is an instance. Each node runs one or more containerized applications, which are grouped into pods. Containers in pods might share resources such as storage and networking, for example. So we can see here an example of what's going on inside a worker node with multiple pods running containers. Each worker node is managed by the control plane, and each worker node contains all the services it needs to run these pods. Something else we find in the worker nodes is the kubelet. The kubelet is the primary node agent that runs on each node, and the kubelet ensures that its containers are running and healthy, and it can also register the node with the control plane's API server. In the case of Scaleway Kubernetes Capsule, we manage the kubelets for you, so it's one less thing to worry about. Let's look at the control plane now. As I said, previously known as the master node, the control plane controls and manages the worker nodes and their pods in the cluster. Scaleway Kubernetes Capsule takes care of all management of the control plane for you. The control plane, we don't need to know so much at this level what's going on inside it, but it consists of components including the kube API server, which acts at the control plane's front end, the kube scheduler, which assigns pods to nodes, and etcd, which is a consistent and highly available key value store to back cluster data. And there's a lot of other things going on inside the control plane too. Those are just a few examples. Okay, coming back to our cluster, let's look at the concept of a pool. A pool is a group of worker nodes within the cluster that all have the same configuration. So in the case of Scaleway Kubernetes Capsule, all the nodes in the same pool will be of the same instance type. You can add or remove pools of nodes to increase or decrease the computational power of your cluster. And last concept directly related to Kubernetes here is kubectl. Kubectl is the command line interface for running commands against Kubernetes clusters. So you can use kubectl from your local machine to connect to and manage your clusters from your command line. Let's also look at the idea of managed Kubernetes. Managed Kubernetes is when third-party providers take over some of the responsibility for setting up and operating Kubernetes. Scaleway has two managed Kubernetes products, Kubernetes Capsule and Kubernetes Cosmos. Capsule is our classic Kubernetes offer where all nodes and their pods in the cluster are managed by Scaleway and hosted on Scaleway instances. Kubernetes Cosmos allows you to have multi-cloud clusters with pods hosted on nodes from different cloud providers. In this demonstration, we'll be focusing on Kubernetes Capsule, but in both cases you get a lot of the same advantages. Scaleway walks you through the setup of your cluster and manages your control plane, which in turn manages your cluster, for free. All of the control plane's components and kubelets on the nodes are fully managed. There is no need to connect to your nodes directly, as all actions and configurations can be done from your choice of interface, so the Scaleway console, via the kubectl command, the Scaleway Capsule API, or via Terraform. You can also monitor your cluster from the Kubernetes dashboard web interface. Features that come with our Capsule and Cosmos products include high availability to ensure that a cluster is available at any time, auto-scaling to adapt the number of nodes in your cluster to your workload, and auto-healing to ensure that your nodes are functioning well, and this will restart or replace malfunctioning nodes as necessary. So now we understand a bit about why we need Kubernetes and what its various components are. Let's get on to the practical demonstration part of this video. There will be 4 parts to our demo. So first, we will show you how to create a Kubernetes Capsule cluster. Then we'll show you how to install kubectl and connect to your cluster from the command line. Then we'll show you what a pull secret is, why you need it, and how to create and apply a pull secret for your cluster. And finally, we'll show you how to deploy an application to your cluster. So let's get started. First, we need to create our Kubernetes Capsule cluster, and we'll do that from the Scaleway console. So let's open up the console from our web browser. So we go to console.scaleway.com. I'm already logged in, and you can see that I'm in my Marie Curie account. We're going to go to Kubernetes on the side menu here, and you see we have this option to create a cluster, which opens up the cluster creation wizard, and the wizard is going to guide us through the whole process. So the first page of the cluster creation wizard is about our basic cluster configuration. We're going to choose Kubernetes Capsule as the cluster type. We'll stick with Paris as our region, so this is where the cluster will be deployed. Scrolling down, we're going to stick with the latest Kubernetes version, and we'll call our cluster my test cluster. So let's click next. Okay, the second page of the creation wizard is about our pool configuration. And if you remember, a pool is a group of nodes or instances which all have the same configuration within the cluster. We will start by creating just one default pool, and after creation we can always add more if we want to. So first we choose a zone, which is the location of the nodes within the pool. If you remember, for our cluster region, we chose Paris. So for our zone, we're going to stick with Paris 1 here. Next, we choose a node type. So for us, this means a type of instance. And we're going to stick here with GP1XS for now, but you can choose more or less powerful instances as necessary. Next, we configure our node options. There are three main options available: auto-scaling, auto-healing, and linking to a placement group. Let's just look at those one by one. Auto-scaling, this feature allows you to define a minimum and maximum number of nodes in your pool. With high load, the number of nodes is scaled up towards the maximum, and with low load, it's scaled down towards the minimum. So this is a cool feature that allows you to deal with fluctuation in demand for your cluster's application. But for now, we're just going to leave the feature off. Next, we have auto-healing. This feature performs automatic checks to make sure that your nodes are running and they're healthy, and when they're not, it replaces them. So we're going to leave this feature on. And finally, we have the link to placement group feature. Placement groups allow you to define whether the instances within a placement group should be run on the same physical hypervisor for low latency or on different hypervisors for maximum availability. There's more information about this in our documentation, which I'll link to below, but for now we're just going to leave the feature off. So we'll scroll down, we can check the estimated cost, and we're at the end of the wizard. We can click Create a Cluster, and we can see that our cluster is creating. Okay, so our cluster has been created and we are taken to its overview page. Some of the pools are still creating, but it's basically up and running. For now, our cluster has just one pool, as we can see here, and this pool consists of just one worker node. Remember, the control plane is separate and that's managed by Scaleway. So the next thing we want to do is to connect to our cluster from our local machine. We'll do that by installing and downloading KubeControl, which, as you'll remember from our concept review earlier, is the command line interface for running commands against Kubernetes clusters. KubeControl allows you to deploy applications, inspect your cluster resources, view logs, add services, and much, much more. So let's install KubeControl. I'm going to do this from my Linux machine, but our documentation also has instructions for Mac OS and Windows. Specifically, there's a written tutorial on the doc site, which is the written equivalent of this video tutorial. And from there, you can copy and paste all the necessary commands to install KubeControl. In my case with Linux, I can install with just 3 commands from the command line. So a curl to get the binary, a chmod to give it execute permission, and finally we need to move it into our path. So I'll put a link in the description to the tutorial so you can copy and paste those commands. Let's go to the command line. Okay, so the first command, as I said, is a curl to get the binary. So we'll just paste that, run it, and we have the binary. Next, we need to do a chmod on the binary to give it the permission to execute. So we'll do that. And finally, we need to move it into our path with the mv command. So I already have that copied. Paste it. Once my sudo password, and we're done. So KubeControl is installed. So that KubeControl can now connect to the cluster we just created, we need to download that cluster's kubeconfig file, and that was generated when we created the cluster, and it's available on the console. So let's go back to the console, click on the cluster, we're in its overview page. I'm just going to scroll down and we can see this link, download kubeconfig. I'm just going to click the download file link. I'll save that to my downloads. You can see that it's a YAML file. Okay, that's done. So now that we've got the YAML file for our cluster, we need to do one of 2 things so that KubeControl can connect to that cluster. We either add the kubeconfig environment variable, whose value is the file's location on our machine, or else we move and rename that file to the appropriate place. So I'm going to do the former with the export command to create an environment variable. So coming back to the command line, I'm just going to navigate to my downloads folder and check that that kubeconfig file is there. There it is. And as I said, we just need to create an environment variable called kubeconfig. So let's do export kubeconfig. And then the value is the path on our machine to where that YAML file can be found. So in our case, it's in home, downloads, and then we have the name of the file. Okay, so just to check that everything is working, we can now do kubecontrol get nodes. And we can see that we can connect to our cluster, and it tells us the state of our cluster's nodes. So we can see the name here of our cluster, that it's in a ready state, how long it's been up and running for, and its version. So everything looks good. So we're getting there. We've understood the main concepts of Kubernetes. We've created a Kubernetes capsule cluster and connected to it from the command line with kubecontrol. The next step is to define and apply an image pull secret to our cluster. But what is an image pull secret, and why do we need one? Well, in our previous video, we saw how to containerize an application and create a Docker image of the application, and then we pushed that image to our Scaleway container registry. So logically, our next step is to deploy that application image to our Kubernetes cluster. However, the way Kubernetes works is that we won't push or upload the image ourselves to the cluster. Rather, it's Kubernetes itself that takes charge of pulling the Docker image to its nodes. Now, if our image was in a public container registry, Kubernetes could just pull it. But in our case, and in most cases, application images are in a private container registry. And Kubernetes therefore needs to be given access to this private registry, and the way this access is given is via image pull secrets. You might also hear these called Docker secrets or just secrets. So the image we want to pull is in our private Scaleway container registry, and we need to give Kubernetes a pull secret so that it can access it. How do we create the pull secret? We do it with kubecontrol from the command line. We also need to know our Scaleway API key for this process. Creating an API key for your Scaleway account is very easy, and the documentation that shows you how to do it is linked below in the description. Okay, let's go to the command line and see the command we need to create an image pull secret. So the base command is kubecontrol create secret Docker registry. And then we need to give it some more parameters. First, we need to give the secret a name. So I'll just call it registry secret. Next, we use the Docker server parameter to specify the address of the container registry where the image is stored. So in our case, as I said, I already pushed my image to the container registry in the last video, and it's still there. So I'm going to give it the address of my container registry. So it's okay. Next, we need to give it the Docker username argument, and the value of that should be the name of our specific registry namespace. So in our case, the namespace is video demo. Finally, we need to give it the Docker password. Docker password. And in this case, this is where we need to give it our API key, so it has permission to connect to our container registry. I already saved my Scaleway API key with an environment variable, so I'm going to use that. So it's Scaleway secret token. Okay, so let's run the command. The secret is created, and we can display the generated secret with the kubecontrol get secret command. I'm just going to add a flag, output equals YAML, and this will return the output formatted in YAML. So there we can see our secret. So we've created our cluster, downloaded kubecontrol, generated our pull secret. We're finally ready to deploy an application image to our cluster. We're going to deploy the Who Am I image that we pushed to our registry during the previous video. Just to remind you, it's a simple image. It's an application that prints out its container ID via an HTTP service. So how do we deploy an application? Well, first we need to create a YAML file to define our deployment. So let's go to the command line. So I'm going to use Nano to create my deployment, and I'm going to call the file whoami deployment.yaml. Let's open that up. And I've already prepared the code for the file, so I'll just paste it in. And we'll look at it line by line to make sure that each part is understood. Okay, so API version. This specifies which version of the Kubernetes API should be used to create the object. So in this case, v1. Kind specifies the kind of object defined in this YAML file. So here we're defining a deployment. Other Kubernetes objects we can define in YAML files include pods, secrets, namespaces, and much more. For now, we're just concerned with deployments. Metadata helps to uniquely identify our deployment object. So we give it a name and a label. Spec shows the desired state for the deployment. So we can see that we're specifying 2 replicas. And the selector field defines how the deployment finds which pods to manage. In this case, using the label, my deployment, that we just defined. Template labels the pods with that same label and tells them which container to run. So in this case, we're calling the containers my container, and it tells, we also specify where to find the image. So in this case, we're giving the path to our Scaleway container registry and the test whoami image. Finally, we give it the pull secret that it needs to connect to that registry and pull the image. So it's the registry secret, pull secret that we just created now. This is a very basic deployment YAML without much customization, and you could probably just take this same file and replace the image value, so the path to the container registry, for your desired image, and for simple deployments that should work. Okay, so let's save and exit. I've just noticed I made a typo in the name of my file, but let's hope that doesn't matter too much for now. Okay, next we're going to use a kubectl command to deploy the deployment on the cluster. So kubectl apply and the F file, and we tell it the name of the file where we have the deployment. So whoami deployment with a typo .yaml. So that's being carried out. And we can see that the deployment has been created. Okay, we can check that everything went well with our next command, which will list all of our cluster resources. So kubectl get all. And we have a good output from that. So we can see we have 2 pods which are running. We have our Kubernetes cluster IP service, which gives the external IP of our cluster. We have our my deployment object, and we have our replica set. So for a final check, we can check that the app is running by using kubectl again and the logs command. And then I'll just pick one of these pods here. Paste that in. Yep, we can see that that pod is listening on port 8000. So we could just stop there because we've deployed our application, and from our kubectl commands we can see that it's up and running successfully. But as a little extra, I'm just going to do a few more steps to expose the port that the application is running on so that we can actually go to the endpoint of the cluster's external IP and see that the application is doing what it's made to do, which is to print out its container ID via an HTTP service. So to achieve this, we're going to expose the whoami application using a node port. Node port is a Kubernetes service which opens a port on every node of your cluster, and any traffic the cluster receives on this port is forwarded. So let's go to the command line. And the command we need to set up our node port is kubectl expose deployment. The name of our deployment, as we defined it, is my deployment. The type is going to be node port, as I said. And we know that the application is listening on port 8000 because it just told us. So that's the port we're going to use. Okay. Next, we can use the get service command to check that the node port service is there and is working. So kubectl get svc. Yep, we can see that both our cluster IP service and crucially our node port service is listed. So node port we can see is mapping port 8000 to 32607. I'm just going to copy that because we're going to need it in a minute. Next, we can use our kubectl get nodes command with an extra parameter this time, O-wide. And this parameter allows us to see even more information about each node. So let's run that. Okay, so among this extra info, which is too big to display on one line in my zoomed in terminal, we can see the external IP, which is here. And this is what we're going to need to demonstrate that our application is working. So we're going to go to that external IP in a command line, in the browser, sorry. Let's go back to a browser. And then, of course, we also need the port, which I've already forgotten. So let's copy the port again from here, back to the browser. And there we go. We can see that the application is printing out its container ID, my deployment, followed by this number. So everything is working exactly as it should be. So we're done. We've seen in this video the key concepts of Kubernetes and how pods, nodes, and clusters all relate to each other. We've seen how to create a Kubernetes capsule cluster in the Scaleway console, how to install kubectl and use it to connect to your cluster from your local machine from the command line, how to create an image pull secret and assign it to your cluster so that it can pull container images from your registry, how to create a YAML file to define a Kubernetes deployment and then get that deployment up and running on our cluster. And as a little extra, we saw how to use the node port service to expose a port on each node that lets us then see what was going on one of our node's HTTP TCP endpoints, where our deployed application was printing out its container ID. In the next video, we'll be showing you how to load balance your cluster, which allows you to efficiently distribute network traffic among the nodes and pools of your cluster. This lets you maximize availability and scalability, some of those key promises of Kubernetes. Don't hesitate to try out this tutorial for yourself. All the code and the files you need are right here, so linked in the description and available on our documentation website. Thanks very much for watching.